In this video, we're going to complete the Factorial Designs practice lab. Here's the problem. A local charity is interested in promoting the social and academic well-being of children in the community. The charity creates an after-school enrichment program for children in grades 6 through 8. So these are middle school kids going to an after-school program. The free program is advertised to parents of middle schoolers, 40 of whom apply to the program. Half of the children are randomly assigned to participate in the program, and the other half are placed on a wait list. After 3 months, all of the parents, including those on the wait list, report their child's current grade point average on a scale of 0, which would be all F's, to 4, which would be all A's. In addition to GPA, the parents are asked to report demographic information, such as the family's annual household income. The goal of this analysis is to determine whether participation in the after-school program has a significant effect on children's grades. So what do we have here? This is an experimental design. In an experimental design, the independent variable is manipulated, and we look to see what the effect is on the dependent variable. So in this situation, the independent variable is participation in the after-school program. So our independent variable is the after-school program, and the dependent variable is GPA. So we're interested in the effect of the after-school program on GPA. This independent variable has two levels. We have the treatment condition, and these are the children who went to the program, and then we have a control group. These are children whose parents wanted to enroll them in the program, but they were placed on a wait list. That means that they're going to do it later. So a wait list is a way of ethically running an experiment where you don't deprive these kids of the benefits of the program that you think there's going to be benefits, so they don't miss out. They just get the program later. That way you can have this other group serve as a control group. So after school program is your independent variable. It has two levels, the treatment and the control. The outcome is GPA. The goal of the study is to determine whether the intervention, whether in the treatment or the control group, has a significant effect on children's grades, on the GPA. Okay, let's go ahead and move forward. Examining the main effect of program participation. Main effect, what does this mean? Okay, when we talk about the effects of different variables on some kind of outcome, the main effect refers to the effect of one independent variable. Now, this is a lab on factorial designs. In a factorial design, you have more than one independent variable. So it hasn't been mentioned yet, but we can infer that somewhere later in this assignment, another variable is going to be introduced, and we'll look at how those variables may even interact with each other. But right now, we're interested in the main effect of the first independent variable. So the main effect is the effect of this variable just by itself. Nothing else is being taken into consideration, which is what we have here in this situation. First, we'll compare the GPAs of participants with those of waitlisted students. So we have the waitlist kids on this side. We have the participants on this side. So we have a box plot right here. What does a box plot tell us? Well, box plot gives us the median score. So the center line in a box plot is the median. It's not the mean, it's the median. Many students confuse that, and they think this is telling us the mean, and it's not. It's giving us the median score, and it gives us the range. This is the lowest score and the highest score. Okay, so the waitlist kids have what appears to be a lower median. Right, if we were to kind of draw a line from there to there, there appears to be a lower median, a wider range. So both of them have kids that are scoring all A's, but the participant group, their GPA drops to maybe a little over 2, but with the waitlist kids, their GPA goes all the way down closer to 1. So we have more variability in the waitlist group. We have lower, the range extends lower in the waitlist group, and we have what appears to be a lower median in the waitlist group. So let's go ahead and make a note of these observations right here. So the waitlist group appears to have a lower median score there is more variability in the waitlist group, and the range of the waitlist group extends lower than the participant group. Okay, so just looking at this by itself, it does seem to suggest that the intervention may have been somewhat successful, but we still don't see a big difference in the average score, but something appears to be going on. So this tells us there may be a little bit more to the story. Something else is contributing to the student's success other than just the program, but for some students it does appear to be successful, right? Because no one has very low GPAs in the participant group. Let's continue. Examine the descriptive statistics table above. Which observed mean is higher, and by how much? What does this mean practically? Okay. So how is this different than the graph we just looked at? So up here we have the medians, did not tell us the mean. Down here it's giving us the mean and the standard deviation. So which observed mean is higher? Okay, so which observed mean is higher? Let's take a look. 2.946 versus 2.642. This one is higher. This is a bigger mean. And this is the participant condition. So this was, they did have on average higher grades. By how much? Well, let's just do the math here. So 2.946 minus 2.6425 is 0.3. So there's a difference of 0.3035. Let's see here. Standard deviation ranges from 0.48 to 0.77, so roughly half a standard deviation. So it appears to be of some practical significance. So let's go ahead and make a note of that. Okay, so on average, the participant group had a higher mean GPA of 2.946 compared to the mean of the waitlist group, which was 2.6425. The participants group mean. The participant group mean, let's go with that, was a 0.3, what was our 0.3035 higher, which was about half a standard deviation, suggesting some practical significance. Okay, so again, I'm looking over here at the standard deviation. It's ranging from about 0.5 to 0.7. 0.3 is about half of that. So when you're talking about practical significance, oftentimes it's useful to look at that relative to the standard deviation. How much variability is there? If it explains kind of a good chunk of that variability, then we'd say there's some practical significance here. Okay, let's move forward. Examine the t-test results above. So there's a table from a t-test. So when you're comparing two means, the statistical test to accomplish that is a t-test. In this situation, we are comparing two independent groups, the participant group and the waitlist group. So we're using an independent samples t-test. So here we have the t-test statistic, the degrees of freedom, which is the sample size minus 2. So 20 plus 20 is 40, minus 2, 38. The significance level, that's the p-value, the mean difference. We already calculated that. That's the same as what we have up here. And over here is a confidence interval of the difference. So let's take a close look at this. Examine the t-test results table above. The significance level is 0.146. So in other words, p equals 0.146. Is the difference statistically significant? And what does this mean? So let's take a look at this here. So here's our test statistic. And then here is our p-value. Now, in order to be statistically significant, p must be less than 0.05, right? P must be less than 0.05 in order to have statistical significance. So let's take a look at this value here. Is 0.146 less than 0.05? In this case, it's not. It's greater than 0.05, or it's 0.05 or above, I should say. So it is not statistically significant. So even though there may be some practical significance to this difference, there does not appear to be a statistically significant difference. So let's go ahead and make a note of that. The significance level of the test was 0.146, which was greater than the cutoff of 0.05. Because P was not less than 0.05, we can say that the difference was not statistically significant. Statistically, the two groups were tied. Okay, so what does this practically mean? It's a tie. So even though the observed mean and the observed median appeared to be better in the participant group, and that difference appeared to be of some practical significance, there was no statistically significant difference. This is a statistical tie. So far, there is not statistical evidence supporting the efficacy or the usefulness of this after-school program. Based on the analyses we've conducted so far, does it appear the after-school program has had an impact or an effect on students' GPAs? Why or why not? Statistically, no. So although the observed median and mean of the participant group was higher than the waitlist group, this difference was not statistically significant. If we wanted to report these results using APA conventions, we'd have the test statistic T in italics, the degrees of freedom, which is 38, space equals space 0.146, comma, P equals, excuse me, this is the test statistic, 1.486. There we go, sorry about that. P equals 0.146. So this tells us the tests we're running, the degrees of freedom, the test statistic value, and exactly what the p-value is. We can see this is not less than 0.05, so this is not a statistically significant result. Therefore, we do not have evidence that the after-school program was effective at raising students' GPAs. Now, just on this alone, does this mean it was a bad after-school program? Does it mean that it wasn't worth it? Well, there could have been other benefits other than their GPAs. Maybe these kids were not getting in trouble, or maybe they were learning social skills or receiving mentoring. Maybe they were learning some kind of enrichment activities. Maybe they were learning art and they weren't being graded on art. There could have been many other reasons why this program may have been useful and beneficial in some way, but the criterion we were given here, GPAs, this is what they were trying to accomplish. We don't see evidence of this, right? So at this point, we would say the program was not effective at raising their GPAs. Now, the story continues, right? So we have other information about these students. We know that they were, let's see, what does it tell us here? We know about their family's annual household income. Right. So now we're going to include this in the analysis and see if this tells us something more. So when people are first learning statistics and they're first learning to do analyses, they would get this far. They might just get this far. Hopefully they get as far as running a statistical test and interpreting that correctly. Many times they'll end right here and they'll say, okay, done. It didn't work. End of story. But we always want to dig a little bit deeper. If we have more information, we have more theories we could explore, we want to do that. We might miss out on something really important. So let's go down here and examine the main effect of household income. So the charity is somewhat discouraged by the results. Well, sure they are. They probably put a lot of time and money into this program, a lot of energy. They staked their reputation on it, and more than anything else, they care about these kids. They want to see them have better futures and better outcomes. So they are discouraged that there doesn't seem to be any benefit to their program. However, they recognize that the children in their experiment come from both high-income and low-income homes. So there's some other variable that might be at play. They begin to wonder whether household income should be considered in the analysis. They decide to compare the GPAs of high-income students with those of low-income students. Very interesting. Let's take a look at this graph. Examine the box plot above. What does this tell us about the two groups? So now we're still looking at GPA. That's still our dependent variable, but we're looking at income as the independent variable. Typically on graphs, independent variable goes on the x-axis, dependent variable goes on the y-axis. Independent variable predicts dependent variable. So here we have, let's see here, I know what I can do. So here we have income predicting GPA. So there's our model. Taking a look at the box plot, if we look at the median for the high income group, it is clearly appears to be higher than the low income group. There's quite a bit of a gap here. The variability within the two groups is roughly the same, so we'd expect the standard deviations to be quite similar between the two, but there does appear to be a gap in the median scores. So let's say something about that. Let's see here. You know what? Let's see here. There's my text box. Click the wrong one. There we go. So what does this tell us? The median GPA of the high income group appears to be much higher than the median GPA of the low income group. All right, low income, high income. The variability within each group appears to be roughly equal. Okay. Let's see, and let's put this in really simple terms. It appears that children from high income homes earn better grades than those from low income homes. Okay, there we go. Examine the descriptive statistics table. So this gives us a little bit more information. Now we get the mean. So let's take a look at the mean. High income group, mean of 3.16 versus 2.42. So we have basically a B average versus a C average. Standard deviation, a little bit higher in the low income group, but still closer than apparently in the other one. What is the observed mean? How much higher is the observed mean? So let's see here. So the high income group has 3.16. What's the difference? 3.1625 minus 2.426. Difference of 0.73. Our standard deviation on average is about, let's say, 0.5. So this is actually greater than a standard deviation. So this appears to be a huge difference. A huge difference. So let's say something about that. The observed mean of the high income group is higher than that of the low income group. There is a difference of, and what was that difference? It was about 0.7365, which is more than a standard deviation. This suggests that the difference is practically significant. So explaining some of the language I'm using here, when we say the observed mean, what we're kind of doing is emphasizing the fact that we're not doing a statistical test yet, so we're not saying that this group is higher than this group, we're simply saying that this statistic is higher than this statistic. This 3 is more than 2 is really all that we're saying, but we're not saying there's a statistical significance. And then here, because relative to the standard deviation, when you subtract them, you get 0.7. That's more than either of these. It means that practically this is a big deal. We still haven't determined whether or not it's statistically significant. For that, we need the t-test, the independent samples t-test, to compare those means. And that's what we have right here. Examine the t-test results above. Let's take a look. Okay, so our t-test statistic is 4.26. Degrees of freedom is the same, 38, because the sample size has not changed. The significance level, or the p-value, is 0.000. The mean difference is 0.7365. That's what we calculated before. And our confidence interval of the difference between the means is 0.3 to 1. So the significance level is 0.000, meaning that p is less than 0.001. Is this statistically significant? Okay, in order to be significant, p must be less than 0.05. So is nothing less than 0.05? Why, yes, it is. So we do have statistical significance. So let's say something about that. The significance level of the t-test is 0.000, which is less than 0.05. This means that the difference in the GPAs of the two groups is statistically significant. If we want to report this using APA conventions, we'd put a comma there at the end of our sentence, T in italics, degrees of freedom is 38, space equals space, 4.262, comma, P in italics is less than 0.001. There we go. So this would be the next highest cutoff point, 0.001. So yes, it is statistically significant. Okay, the children from high-income homes had significantly better grades than those from low-income homes. There we go. So examining a possible interaction effect. So we've looked, now we have two variables in our analysis. We began with just the after-school program, treatment versus control being the only independent variable. We looked at the main effect of that. So the effect of one variable, one categorical variable on one continuous outcome. And then we were interested in the second variable, household income. So we looked at the effect of just that independent variable, money on GPA. So that was another main effect. Now we're going to look at the effect of these two variables taken together. And what we're looking for is a possible interaction effect. So an interaction is when the effect of one variable depends on the level of another variable. So if you were to ask the question, does this program work? And the answer is, well, it depends on something else. That's an interaction. That's what we're going to explore here. So we're going to see is there an interaction between program participation, participant versus waitlist, and household income, low versus high. In other words, they wonder if the program may be more effective than for some children than others. So why would this be? If we know that the high-income kids are all doing quite well on their grades, look at this. No one's even scoring down in the 2 range, maybe 2.5, somewhere in this ballpark. They're all doing relatively well. There's really nowhere for them to go. You could have this great program, but they're already doing pretty well. Whereas the kids from low income, they're kind of here in the middle range. There's room for improvement. So it could be that the program will help these kids more than it helps these kids. And that's what we're exploring. That's an interaction effect. So here is descriptive statistics broken down by income level by participation. So let's take a look at this and make sense out of this table. There we go. So among the wait list, so these are kids that did not go to the after-school program. This is the control group. CT stands for control group. The low-income kids had a mean of 2. So basically C's. The high-income kids had a mean of 3. So roughly B average. Among the participant group, TX stands for treatment condition. The low-income kids had a mean of 2.74. The high-income kids 3.15. So if you look at the high versus high, 3.15 versus 3.17, those are very close. There's not really much of a difference. So if you're only looking at high-income kids, it doesn't really matter which group they're in. They're scoring about the same. They basically have a B average. But if you look at the low-income kids, those who were not in the program, the control group, 2.1 versus 2.74. So the mean is a lot higher for the low-income kids when they're in the after-school program. They're participants, they're in the treatment group. So there it suggests here that there could be some kind of an interaction at play. So we're going to graph this. When you look at a graph, that can be one of the best ways to detect an interaction, I should say, is by taking a look at a graph. So we're going to graph this and see how that looks. So we're going to graph these four means. So let's start with wait list and participant. So and we're going to put high income and low income on different lines. So place program participation on the horizontal, separate lines for income groups. Okay, let's explain what that means. So let's start with the high income kids. We'll graph them first. So the high income kids on the wait list, their mean was 3.175. 3.175 would be, let's see, that should be a 3 right here. So 3.175 is going to be right around here. So these are high income kids on the wait list. What about high income kids in the participant group? Okay, high income kids participant 3.15. Okay, so we go over here, 3.15, right in between these two. So right about there. Okay, so high income kids, we draw a line between these, if it'll let me do that. Yeah, it's a little unhappy about me trying to draw on top of my drawing. There we go. So these are my high income kids. High income. So whether they're in wait list or participant groups, doesn't seem to be much of a difference. Okay. Now what about my low income kids? Okay, low income wait list is 2.11. Okay, so 2.11, 2.1, right around here. See how big difference right there. What about low income participant? Is 2.74. Okay, 2.7 is here, 2.74 is going to be about right there. So if we were to draw a line between these two, if it'll let me do that, it's going to look like this. Okay, now let's look at, let me label it. Okay, so this is low income. So when we have an interaction, it's going to be apparent visually because these two lines are not going to be parallel. So if we had, if low income looked like this, there would be no interaction. You'd say, okay, well, low income always did worse than high income. Doesn't matter if they're wait list or participant, only income made a difference. But that's not what's going on here. We don't have parallel lines. If you were to extend these lines further, they would cross. Right? Now they don't have to actually cross in the graph. Sometimes they will cross in the graph when you have an interaction. In this case, they don't actually cross, but they're certainly not parallel. So this visually suggests some kind of an interaction in play. The effect of the program participation depends on income level. With high income, there's no effect. With low income, there appears to be a huge effect. So this is what an interaction looks like. Okay, so this is a visual representation of an interaction. Inspect the plot you created. Do you see visual evidence of interaction effect? Yes, we do. Let's explain. There does appear to be visual evidence of an interaction effect. The two lines are not parallel. Among high income children, there does not appear to be an effect for the intervention. However, among low income children, there appears to be a strong positive effect. Okay, let's see here. Oh, that should be capital. So if we're to summarize that, we would say, thus, the effect of the after-school program depends on the income level of the child. it seems to work well for low-income children, but does not seem to benefit high-income children. That's an interaction. Now, is there a statistically significant interaction? So you could have a situation where you see this pattern, and even though there appears to be an interaction, just like, remember the first graph, this group appeared to be higher, but it wasn't statistically significantly higher because P wasn't over 0.05. Here that appeared to be higher, and it was statistically significant, P was less than 0.05. This interaction that we're describing, that the effect of the intervention is different for the two groups, well, we can test that statistically as well when we use a factorial design, a factorial ANOVA. So here, this statistical test looks at each main effect by itself and then the interaction effect between the two independent variables. Let's take a close look at this table. So we have three effects that we're going to be considering. We have the program. So that's program participation, whether they're in the participant group or in the wait list. We have the income level of the child is another main effect, and then we have the interaction effect, the interaction between the two variables. This is an asterisk, which is basically the same as a times sign. So it's the program effect multiplied by income level. So that's the way we'd symbolize an interaction effect right there. So we'll start with the main effect of program. To interpret this, we go all the way across to the significance level, right? This is the p-value. So it is 0.068. Is that less than 0.05? It is not, right? So 0.06 is not less than 0.05. It's greater than. So there's not a significant main effect for program. What about for income? 0.000. Well, 0.000 is less than 0.05. So we have, I'll put a check mark there. So yes, we have a significant effect, a significant main effect for income. What about the interaction effect? Program times income, 0.049. Well, 0.049 is less than 0.05, just barely. So we do have a statistically significant interaction effect. So although overall there was not an effect for the program, we can see that there was an effect when you take into consideration the income level of the child. So examine the table. The significance level for the effect is 0.049. Is it statistically significant? What does this mean? Okay, so let's say something about that. So the significance level of the interaction term would be another way of describing this line in the output here, or this variable. So the significance level of the interaction term was 0.049, which is less than 0.05. Therefore, the interaction effect was statistically significant. What does this mean? Well, we've taken a look at the graph here. Clearly, what's going on is the program works well for the low-income kids, has no benefit for the high-income kids. The after-school, oh, good job. The after-school program improved the GPAs of the low-income children, but it had no measurable benefit for the high-income children, just based on this one analysis and this one variable. So we wouldn't say that the program was bad. It certainly didn't seem to hurt the high-income kids, and it may have benefited them in some other way. Maybe they made more friends. I don't know. But we weren't measuring that, and we weren't analyzing that here. We were focused on just GPA. So a conclusion, based on the analyses above, what can we say about the effect of the charity's after-school program on children's GPA? How might you explain these results? Okay, so reiterating what we just found out, we could say that the charity's after-school program had produced positive effects or produced benefits for low-income children, increasing their GPA. How much was the increase? We didn't talk about the practical difference. If we take a look at the low-income kids here, it went from, let's see here, 2.742 from 0.22. So we have a difference of 0.6. Standard deviation is probably about 0.5. So this is more than a standard deviation, so it is a big difference, a sizable difference, increasing their GPA by a sizable amount, right? So had a big effect, lots of benefit on the GPA. However, there was no measurable benefit for high-income children. They, on average, high-income children had high GPAs, whether or not they participated in the after-school program. Okay. How might you explain these results? So why would this be? Does it make sense? And why would this be? Well, it could be that the higher income kids had other resources available to them. It could be that they were in, maybe they had tutors, maybe they had more resources in their homes, maybe more books. Their parents might be better educated and more capable and available to tutor their children or give them extra help with their homework. Maybe they have internet access where they could look up YouTube videos that could help them with their assignments, and maybe the low-income kids didn't have access to a computer where they could do that. Maybe they had better study environments. Things were quieter. There were less people in the house, so they had more room and to study and pay attention to their work. Maybe they have better nutrition, which allows them to concentrate better. Maybe they're getting better sleep at night. So there could be many, many different reasons for this. So we could say, we could list a couple of these. This makes sense because the high income children may have other resources available to them, such as better educated parents, outside tutoring, and internet resources that are not as commonly available to the low-income children. Thus, the low-income children relied more heavily on the after-school program, right? Something like that. So the high-income kids, they have all sorts of resources available to them. This wasn't as important to them. They could take it or leave it because there's other things to help them out. The low-income kids, maybe they don't have anything else to really help them out. So this made a much bigger impact, benefited them a lot more. Assuming the experiment is internally valid, is it reasonable to say that participation in the after-school program caused a student's grade to improve? So a couple of things to look at here. Internal validity. What does this even mean, internal validity? When we're talking about an experiment, internal validity means that the independent variable is what caused the change in the dependent variable, not some other extraneous influence. So we always have to consider the possibility that some other force was at play and consider that. For example, let's suppose that during our experiment, the kids went into a new grading period. And when they started the new grading period, the grades started over. So, some kids had high grades, some kids had low grades at first, and then everyone started fresh, and everyone, they have a couple easy assignments at the beginning of the term. Everyone has A's, everybody's happy. So all these kids' grades have gone up in terms of GPA at this point, but it's not because of the experiment, not because of the after-school program. It's simply because of a change in the grading period. Now here we have a control group to help with that. And that's the value of a control group, because if that had happened, that would affect our control and our treatment group. But here we see a difference for the treatment group and not the control. And that gives us more confidence in the internal validity of the experiment. But those are the kind of things you want to watch out for. But assuming that the independent variable is what is truly associated with the change in GPA, then is it fair to say that the program caused the grades to improve? So in a study where it's simply a correlational study, you collect data and look to see how two variables are correlated, you have to be very careful not to use or very tentatively use causal language or make causal inferences. The purpose of an experiment is to infer causality. We are manipulating the independent variable. We randomly assign some kids to be in the group and some kids not to be in the after-school group. And because of that, we can say that this difference caused the change in the GPA, again, assuming internal validity. So yes, that's the whole point of an experiment. So oftentimes we drill into students' head, correlation does not equal causation. Correlation does not imply causation, and so on and so forth. So everyone, oh, I don't know, I don't want to say it caused it. I'm nervous to say that. But an experiment, that's the whole point of an experiment, is to be able to make a causal inference. So we can say because the independent variable was manipulated by the researchers, in other words, i.e., students were randomly placed into treatment conditions, we can infer that the program caused a change in GPA. And I'm going to put in parentheses because you know there's an interaction here among low-income students. We don't want to forget about that because we did find that there's an interaction effect. There was no benefit for high-income kids. So we're gonna just reiterate that here. Caused the change in GPA among low-income students. We can be more specific. Caused an increase in GPA among low-income students because we did say that the numbers went up. Right. So there was not just a change, there was an increase. As a behavioral scientist, what advice would you give the charity regarding the after-school program? So finally, we're talking about the implications. So far we've said, here's what the data say, here is our conclusions of our analysis, but what do we actually do with this information? What advice do you give to the charity? Should they shut the program down? Should they keep the program going? So a couple of thoughts that come to mind. First one has to do with the observed interaction effect. So because there was a significant interaction effect between program participation and income group, the charity should focus its recruitment efforts on low-income households if improving GPA is its primary objective. Okay, so if you're about GPA and this is what you're trying to accomplish, don't waste your time on the high-income kids. I mean, you're a charity. You're using maybe donated money or grant-provided money, foundation-provided money. You have limited resources. You can't put every kid in this program. So if you're going to recruit, advertise, and try to get kids to participate, why don't you aim for the low-income kids because they're going to benefit, whereas the high-income kids, they may like it, but they're not going to benefit. Now, it's possible the charity is not only interested in GPA. It could be that that's what they focused on at first, assuming there would be this benefit, but maybe there are other benefits to the program that could equally apply or maybe more so apply to the high-income kids. So we could suggest to them to explore, to measure and explore other outcomes of the program if they want to remain open to all children. Okay, the charity should also consider measuring outcomes other than GPA if it is interested in supporting the growth and development of all children regardless of class. Okay, so if you want to help everyone, you don't want to leave out certain kids, you want to make this available to the community, then GPA is not gonna be benefited for everyone, but there could be something else. So we might suggest what those could be. Maybe it's improved social skills. So we could make an example of that, social skills. Maybe the high-income kids learn better social skills by participating in this program. It could also be virtue development. I don't know what this program does, but maybe they're teaching them virtues, teaching them how to be more pro-social and more caring and more generous to others. So they could support that, they can measure that, and if they find a significant impact there, then they could say, hey, our program is benefiting everyone. For some kids, it benefits their GPA. For other kids, it benefits some of these other ways. But our program is sort of universally effective. So those are the options that the charity might consider exploring. Hope this was helpful to you, and as you move forward into the next stage of the assignment. Thank you.